Welcome, I'm Bill Wake. We're working on a programming language interpreter and compiler for a language called 10th. We made it up. It's very similar to 4th. And lately we've been working on making it so we can read a single character, as we want to have that support in our language. We haven't worked on the language side yet. We're still working on entering raw mode or going back to cooked mode. Raw mode is single character at a time input. In pure form, it doesn't even, it just returns control C's and other control characters directly to you. We're kind of in that intermediate one that's sometimes called C break or half cooked, that we're going to have support for hitting control C to exit, but simple characters will be read in as one character. Now our REPL, the read eval print loop, it needs to get a line at a time. So we have a conflict that if we put our code in, we put our system in raw mode or C break mode, then our REPL it's thrown off because it's getting characters one at a time and it thinks that's the whole line, and it's not good. So we need to explore, and mostly it's make a decision. So one option would be stay in raw mode, and then we'd have to build a little editor for our read eval print loop. We'd have to make every character input kind of accumulate into a buffer, and make, if we hit a delete key, do the deleting, decide if we're going to do stuff like support control A or control E to go to the beginning or end of a line, arrow keys, whatever else we can think of. It's a moderate, I mean, it's not an impossible project, but it's a little bit of work to build that editor. Or we could do something where we track raw or cooked mode, and when we're reading characters from the user, we stay in raw mode, but when we go back to the REPL, we'll go into cooked mode, and then maybe at the end of the REPL, we'll restore raw mode, or, make each individual command do it or something like that. So that's kind of the big picture decision. I think the cheapest way out I can think of that might work is the last one there. Enter raw mode whenever you want to read a character. So when we ask for a character read, we'll enter raw mode, read the character, go back to cooked mode. Then when we get to the REPL, we're in cooked mode, and we're only reading in raw mode when we specifically want one character. All right, so I think we'll try it and see if that works. Now, it's not a given that it will, because I don't know how quickly it goes from raw mode to cooked mode and all that. I mean, it's a couple of procedure we call a couple of procedures to do it, but I don't think it's going to be amazingly slow either. I think it'll probably work. So we'll try that first. Probably if that doesn't work, we'll probably go to the tracking idea. So when you go into the REPL, we'll switch back to cooked mode, and when it goes to run, it'll check the flag and decide if it should enter raw mode or not, and it can leave it in there, whatever we do on those lines. Okay, so let's go back where we were yesterday. I'm going to run make, and I think our tests all pass, but the stuff that's not working 100% is the pure IO terminal monitoring stuff. I have no way to unit test that, really. I mean, I could, if I trusted my implementation of getAdder, maybe I could do something where I set and then do a get and make sure the bits that I thought would be set are set and all that. But does it actually go into raw mode? That's something I can't tell by looking at the bits. I could have the bits wrong. The other thing we had was let's see, I opened a second window somewhere here. Well, I seem to have a number of windows open. Oh, yeah. Well, I guess 1625 control 1. 6, 2. Those don't seem to do much. Oh, Alt command. Okay, there's one. So we had something where when we tried to leave it in raw mode, it failed after 2 or 3 calls. I guess on the third call it failed. We took that piece out, and it's just back to cooked mode, and it's okay again. But that made me look around a little, and I think Yeah, so I made a note to myself, double check the index of L flag in io.s. Okay, so it's index. Right, so we defined this constant. So these two are the flags. So bit 3 and bit 16, 17, 16, I guess, are set in a word to turn it into the one of them, echo flag and canon flag. So canon flag is canonical, which is cooked mode. So it starts on and we're going to turn it off. Same for echo. It starts off echoing what you type. Now this, let's go find usages of that. Okay. So entering raw mode, we get the index, which is supposed to be the offset, and then we do clear bits add. Now the problem is it's right at the end. Well, no, clear bits add. We had some discussion about making it count instead of working a byte at a time, make it work a word at a time, where a word is eight bytes. Okay. Now I think we kind of half did. All right. So file descriptor. Right. File descriptor. Well, maybe we didn't. No? Okay. Yeah, we did. All right. So notice this LSL3. That's saying if you give us X1, should be the word offset. Now, LSL3 effectively multiplies it by 8, which is what we want. We want to shift a word counter up because we're doing a word offset from X0. But it used to be a byte offset, and I think part of the problem we have is that the constant is being used as a byte. We've got a byte offset constant and a word offset usage. Okay, so clearing these bits, X1 is index of L flag. Well, I think we multiply this by 8, so that 24 becomes gazillions bigger. So yeah, it needs to be 3 because 3 times 8. Okay, so again, this shouldn't break anything here. Didn't see any red, but keep going. Okay, so the tests are unaffected by that, which we would expect because raw mode is only detectable at the terminal level. All right, now I don't know if we can detect it. Let me do a reset, which should restore the mode to whatever it was, I think. We did this in REPL the other day. Now, okay, so I don't know if we won't leave this here, but this was a check to kind of see the effect of it, and it was crashing after the third call to read word. Now I think, I believe there was a bug in our actual bit setting that is now fixed. Now, whether that's enough to fix this problem, I don't know, but we'll try it. Okay, so let's make clean, make REPL.out. Yeah, this we changed that multiply at the last minute yesterday and tried something and it seemed okay, but yeah, this there's no way this set the bits right. I don't know what it set. Well, I guess it set something. Oh, it could be a bus error there. I don't know. We'll see. Okay, so now it should go one character at a time. A, B, C, boom. Okay, I don't know what that is. It's not, I don't know. It's weird. This is a weird usage that's not the way we intend to use it. So I don't know if that's something that's a real problem. Well, okay, something's good. All right, let's run it again. Notice I type A, but there's no A typed. Okay, so echo mode is definitely off, and it's only returning one character. So there's no processing or any of that. So I think it's clearly setting echo off. I think it's most likely setting the canonical mode correctly because no echo is independent of canonical mode. Canonical mode waits for a line feed, and non-canonical raw mode does not. So I believe we've got the 2-bit set right. What the heck is going on that would cause this bus error, though? B again. Okay. Well, we'll I don't know. I think we'll try it out a little bit, spend a little time investigating, but I don't think it tells us. Well, no, we can have it tell us something. Let's put things back for a minute. io.s. I think when this is 24, we probably don't get our echo mode cleared out. Make REPL.out. Okay, it built IO, so we're good. And /REPL.out. Okay, A. Yeah, so those bits are not set. Okay, so it's clearly in canonical mode still. I can delete. I can use, no arrows, but I can probably hit Control A. Nope. I guess all I have is delete and enter. Okay, so clearly whatever we did really was broken with 24 there. All right, and the REPL is fixed there. Could it have something to do with a string copy of the input? Yeah, I don't know to rule out anything at this point. We'll make REPL again. I put the 8 back, so it should be this. Oh no. Did I not do something? 8. Maybe I didn't save. Okay. Make REPL. Okay. So, I should lldb./REPL.out. Oh no, I don't. Sorry. I want to make sure I'm back to where I was with no echo. Oh. Why is that? I wonder if my makefile is not quite correct. Okay, let's do a reset. Make REPL A, B, C. Well, what the heck is going on here? Now, I would have sworn this was right. I mean, we saw this working with no echo at some point, so I'm very confused here. All right. Oh, thank you. Divided by 3 instead of 8. Like, where's 3 from? Who knows? Let's make, and then we'll make REPL A. Okay, B, C crash. All right, now let's do ldb./REPL.out. We'll see if we can figure out why that third one is the problem. I'll just go into run. I wish I could turn this off permanently, but anyway. Okay, A, return B. All right, we crash. Find trailing space or new line. Okay. Well, why it's crashing, I don't know. What's X22? And I don't remember what our X22 is even. Is it our... I don't think it's our stack. Word pointer, current word. Okay. Um, let's look at that code. So we're storing a 0 byte, back 1 from the counter. I don't, well, no, we work, well, we'll go back and look, but we have done plus and times and stuff like that. So we've done one word or one letter words. Actually 0 and 1, we do that way. All right. This is find trailing spacer NL. And it's the stirb. And where's that file? REPL.out? Find trailing spacer NL plus 24. Well, 0, 8, 16, 24. Well, no, that can't be the problem. If the stirb, well, I guess I sure wouldn't think. So the store byte, we're writing a 0 into the slot where the next word is. Back from where next word is. Okay, so we've loaded next word. We've incremented it beyond the character we're looking at. Let's say that's the C. And we compare that character to new line. No. To space. Well, I guess it should be new line. Yes, right. So, oh, yeah, no. Okay. I think what's going on is I think it'll store the buffer them back, but it doesn't put the new line in. And we definitely built our input to assume there's a new line at the end of the input string for the REPL. I'm not sure why it worked for the first two, but it definitely could be. It could just be, dumb chance or something. But yeah, I mean that's kind of a requirement of our input process. Because new line has to be there at some point. So who knows how far we've gone to find a space or new line. But yeah, so I don't think I want to pursue this anymore. If we were doing the edit our own, then maybe. Oh, now this read string. Look for contents of quoted string. Okay, so well, this one. I think this commented out code was a discussion about should we terminate a string automatically at the end of a line. And right now we're not. We just keep going. That seems a little flaky. Okay, so move back 1 for each letter. I would have thought, well, let's check that. I would think that read word. Well, read line calls read word. Is that right? I mean, when we read a new line, we start at input buffer and put it there. So I think that's there that is hard coded to always start at the start of the buffer. So now let's make sure input buffer is the right entity. Input buffer. Okay, there it is. Yeah. So I think we're okay there. I do want to capture this string, though. I think we should put a note in and at least acknowledge that we don't handle new line in a string. Oh, what if strings don't end by the end of the line? Okay, yeah. So I think the REPL just does not work without new lines because we use those to detect the end of a string we're going to process. So it's being asked to do something it wouldn't normally be asked to do. Okay, so I think where we are is we fixed that thing on the inner raw mode where it was just pointing, going off to some byte count instead of a word count. That feels like the right thing. I feel bad that I didn't detect it by any test, but I didn't. This is REPL in cooked mode. Okay. Okay, so we've done that. Good. I think we're there. Okay, so let's fix this. Let's get to our other window, whichever one it was. Well, I don't know that that's quite right, but we'll be okay. All right. So let's do a make. Well, let's do a clean make and a make. Make sure all our tests are still green before I push this change. We're pushing the word change. Okay, green, green, green. All right. Let's see. Correct. Whatever that name was. Okay. So, what do I think? Well, I think we're to the point of saying, what's our read routine look like? Okay, read from a file. I'm going to see if we can get by without that, but read from a terminal we really want. Because our hangman game, we're going to write, you're going to enter your guess and, do you have any E's or whatever? And that should work, as a terminal kind of application. All right. So I think what we'll need to do then, I think we need a command. I mean, a word in our 10th language that reads a character. Yeah, getc, that's a good name for it. Okay, so getc gets one character, pushes it on the stack. I'm going to say as an integer. We may. Now, do I need... I don't see a way to test this automatically in any kind of sensible way, because it's going to be screwing around with the terminal, reading a character from the terminal, and then putting it somewhere. So I think we'll do a manual test which means I just have to write code, I guess. Return. All right, so it's going to call things. So we need a standard prologue and a standard epilogue. And then I think our approach was going to be set enter raw mode, read one character, and then exit raw mode. Okay. And the character reading, well, we're doing it in REPL now, so let's go get that back. Okay, I'm going to take this out. Okay. But read word, that's an input, I think. I want to find an actual read command somewhere, Unix read. Is that what we called it? Where's that macro? Unix read. What? There we go. Okay, input.s, read buffer. Okay. So it's something like this, but it's not this. All right. Getc in io. Well, I'll just paste it here like that, left justified. All right, so one thing I know is we need a data segment, and let's make it aligned, and then go back to a text segment aligned to, okay. And we're only going to read one character, so I'll just put a one, I'll just do a quad word buffer. Is that going to work? I think so. We'll just allocate that. So this is getc buffer. And it's just a quad 0. Okay, so 0, this is the file descriptor. Did we really? I guess we did. Yeah, okay. File descriptor, input buffer. All right, X1's the input buffer, which is this. And then X2 input buffer size is just 1. We're doing a one character get. Okay. Then the Unix read. Well, wait a minute. Something's redundant here. X0 file descriptor, X1 address a buffer memory. Then what's this parameter doing? No. That seems like it could be better. let me make a note. Maybe we're going to put those in there and we wouldn't need them in the macro at some point. Okay. But I'll at least use the stuff I'm using here. Okay. I think I intended to let these go away, but if they're not used, I don't see FD either. Okay, so, all right. So we've got a byte. Now, getc's job is to take that byte and push it on the stack. All right, Now, I think the reason I made it a quad was to hopefully make that easier. It'll only ever write the first byte, but now we got that in the lower byte because it seems to be, I don't know if it's big Indian or little Indian, but it's backwards from what I'd expect. I guess I expected it to be on the right, which would be little Indian, and this is apparently big Indian. Okay, so we have data push. Well, and a couple of weeks ago, I probably knew what the value. Oh, yeah, just whatever. Right. So let's do load address. X0 is L get C buffer. Load the value at that buffer and then push it. Okay. So does LDRB work to get the byte? Yeah, it probably does. But I think, yeah, it probably does. I still need this address. So I don't think it saves me much. I don't think there's any issue with sign on that, but let's I guess that would just be this instead, but we're pulling the full quad, so it's just already a number read as a number. I suspect that's as easy for it as anything. Okay, so now we need to put this word in, which is in main. Okay, and well, I'll push it towards the back. So getc calls getc. All right, so if this works, test should be unaffected. If I make REPL, so what I expect is if I say getc dot, that it'll take a character, print it, take a character and print it. Print the decimal number of it. Boom. Okay, global. All right, so getc dot should let me, I guess it'll go to the next line and I'll type my 2 letters and then I'll get a printout. Did we change dot to not pop? Yes, we did. It won't hurt anything to have 2 things on the stack though. So it should get a new line to the new line, print some decimal, and I guess I'll do AB, so 65, 66, no spaces, and then print the prompt. Okay, A. Oh, we always print spaces after our numbers, huh? Okay. B. All right, yay. Okay, for all the pain of getting this cooked mode right, this part worked. All right, so, well, we can do a loop. Can I, yeah, that's a good question given our, oh, we didn't go back out of RAW mode yet or something. Okay, getc dot AB. Oh. is that bus error 10? Well, the bus error 10 is because it's not fetching it. Did I call exit mode or did I call enter twice? Let's make sure of that first. Unfortunately, I feel like I typed exit. Yeah, I did. Yeah, let's go look at that and make sure that looks right. Exit raw mode. So it gets that data storage. We put this in. Gets the index of flag, which is now 3. We'll have to make sure we did that in set bits. And then echo and canonical, it clears the bits at? No, that should be set bits. Haha. Let's make sure set bits at is the same way as far as words versus failure. Yeah. Okay. This is promising. All right. But I got to do my reset. Make REPL. getc dot AB. getc dot, and I'll do lowercase ABC. Okay. All right. I think we're there. I don't have quit. Okay. So I have canonical mode is back on, so that seems to be okay. I'm just wondering if could we test that somehow? I mean, I guess the problem is it's getting terminal attributes, right? So once again, the comment and code diverges. I mean, I suppose I could test this code, but we kind of did. Our test for set bit at was basically this code. I don't know. I think it is what it is. Doing this in a method that, yeah, I mean, that's just setting the arguments for the thing you want to set bits. And if you don't set them and you clear them, I mean, I had 2 methods that entered raw mode. Yeah, I don't see a good way around it. We know set bits at works theoretically. We know get bits at works, but you got to call the right method on a routine you're not going to test. And I don't think we can. I don't see a way around that. I guess the only thing I could theoretically pull this into a routine and, but yeah, I mean, honestly, that would be a better thing to do is do that. The reason I didn't, it's embarrassing. I didn't because we don't have a mem copy. Not that we should never have it, but that's why. So I don't know. I think let's take what we got here for a minute. Okay, so make sure everything's green. Okay. And getc, which reads character from terminal. Okay. Oh, that's a nice idea. Okay, yeah, let's do that. Read by character from a terminal. That's getc. Now, notice we don't have anything useful to do with it yet, because we don't have anything that will convert that character into a printable string. We can probably we could probably do it with a little bit of kind of punning between strings and ints and stuff like that. Let me just try that real quick here. REPL. Okay, so if I do $getc, I don't know. Let's just do at, because that's a nice easy one. 64. Whoops. Getc dot at. Okay. Now, because the way we store things with that first byte being the low byte of the string, I bet you, I'm wondering if this will work, because it's got a 0 after it. No, what's our word? Oh, $. No. Okay. Yeah, you got to have a real string to call $. Okay. Yeah, let's go do what you suggested. That's a great lazy way. I mean, it'd be nice to have memcopy for some things, but let's see. So I think what we're doing. Interom mode. And this one is the altered. Okay, so if I get these attributes for that, and then I do it for altered, and then I only change altered. Okay, so that should be fine that way. Now this then becomes L_s altered. We don't need this stuff. Okay. Yeah. Thank you. Altered. Okay. Let's do original here. Okay, I think I'm there. All right. Okay, I'll do a reset. Do a make. Okay, so this, if I do getc dot, that should be enough to show it. It should be back in regular mode when I get out of here. Dot dollar. Well, no, let's do something we can safely do. Okay. Yeah, I like it. Thank you. All right. And we'll do the make. Oh, well, look at the make. Okay. Did I mean to restore it twice? Did I do that? Oh. No. Okay. Yeah, no harm, but not needed. Okay. Yeah, that's nice. A little space is something we can afford. All right. Yeah, I think, well, okay. I think the thing we need to do is find a way to convert that character to a string in a useful way for us. So I think this, what I called make dollar, is going to take an array and convert its data to a string. So let's implement that so that we can read it and print it and build up strings and go from there. Okay, so and then we'll come back to this Unix thing. Okay, so this is make dollar converts array of integers to a string, 1 character per word. I think I'll put the 1 character per word earlier. Actually, it's 1 word per character. Okay, and this is really strings. This is character IO. Okay. Well, this seems nice and testable. All right, so I guess it's a test of strings. And we're going to say make creates string from array. Okay, so just to get the basics here. All right, we'll need to initialize all that stuff because we're going to kind of be in a realistic environment. I want to check variables. Okay, array assign. We just want the create array one. Okay, that's variable. I guess this is, okay, it's checking all those things. So if where's my act? If I do this, array takes an item off the stack and makes an array from it. Okay, so string test. All right, so we're going to, well, let's give it a little room. Okay, so this is make an array. And I guess we're just going to call at whatever on it. Array sign stores A at B indexed by C. Well, I think I have data push ABC. Not dictionary, not Unix. Data push ABC. Okay, that'll work. Okay, and our array at A at B indexed by C. So A is the A is the value to store, B is the address, C is the index. What's that let variable? Well, I think this is doing it a little different. Okay, but B variable address. Yeah. I don't know if we can. I don't know. Okay, I guess I want to make an array. I mean, make dollar should have an array address on the stack, right? So maybe we just put the values in here. Okay, so data P2 line 3, text line 2. Okay, so I think I'm gonna shortcut that because all this is to get an array address on the stack, which we can do fairly easily. Actually, this is almost it. Okay, so this is L make array. And it's going to be quads. Well, let's take at 64. Well, ABC is easy enough. Quad, and quad 0. Okay, so lmake array is now an address with a bunch of words pointing to that as if it were loaded on the stack. So let's do that. Data push x0. Okay. All right. Now this is going to call make. I'm going to call it make string in here. Okay. And the assertion is, well, it should push something on the stack. Yeah, I think okay, whoops, caps. All right, x0, and this is L make expected. Okay, I think we're close. All right, so we push an array address on the stack, call make string. It should allocate storage for this thing and return the address of the string in x0. Oh, sorry, on the stack. So we'll pop that address to x0, pop the expected here, and this should be working. Okay, so let's go to string. What? Don't we have any string functions? Like, oh, eval. Oh, I should call this thing too. This seems like an odd test. I guess eval has read word and all that stuff, maybe? I don't know. It seems like an odd place. Okay. But we have no $sign functions. All we have is print dollar. Where did we put that? Dot print io. Fair enough. Yeah. Okay, I guess string really is empty. All right, let's take, well, this thing will have enough. Core defines assembler macros. Yeah, we'll need both those. Okay, string.s. All right, and we need global. And we need a function. All right. Input.o. I bet that's not in our make file if nothing's using it. Oh, we built it. We test it. Do we put it in our REPL? Yep. Okay. Make string referenced LD minus O string tests. I guess it's here. Okay. So, oh, that's the thing I was trying to do before. So basically, A is I was kind of expecting junk in X0. I should have said explicitly. Certainly not ABC. So I guess we're just pointing, yeah. A is the first quad. So I think the leading, the the rest of the bytes in the word are 0, and the first byte of the next word is 0. So one way or the other, it's going to hit a 0, and that's how it gets to the A. But it doesn't convert, so it doesn't get to the BC. So, okay. Not quite what I expected, but still plausible. Plausible and wrong. Okay. So, well, this thing. Okay, so I guess we need some sort of loop. Okay, so what we're going to do is read bytes from the array, wherever the memory pointer is, and store those bytes into our secondary space, and then at the end we have to round off. So that round off thing has showed up a couple of times now. All right. So I guess okay, we got to do a data pop x0. That's the address of the array, and then well, I guess this is L make loop. We're gonna load x1 is contents of x0. Plus 8. Okay, so it's sort of x1 equals x0 plus plus kind of thing, or add x0 plus plus. Okay, so if I look at x1 and compare it to 0, if it's equal, we'll go to exiting. Otherwise, something happens and we branch to L make loop. And here's L make exiting. So I guess at this point we know x1 is, as a word, it contains at the bottom the byte, or whatever the character is. So we want to do a store byte x1 to the contents of, well, that's where did I lose it? Okay, secondary space. Plus 1. Okay. So I'm storing the byte, incrementing the space, and I think, yeah, I'm ready to go back. Oh, wasn't X, I think X28's our temps, right? Is that free? Yeah, theoretically free. And then X29 is that frame pointer that we don't use, but we could probably use it and not hurt anything. Okay, this seems like an awfully tight loop. Okay, so we load whatever x0 points to, compare it to 0. If it's 0, get out of here. If it's not 0, we store the value at the secondary space and go back for more. Well, x0 is on the next character now, so we load the next character and so on. So that part seems good. Now what we haven't done is we haven't written a 0 yet. So let's store byte 0 into secondary space, add 1. Okay. No, that's the nice part about it, because at this point we're running stuff, so the program is already contained. We are starting with secondary space pointing to some free space. And we can just write that string as long as we leave things, secondary space has to be left rounded off to the next 8-byte boundary, so that the next, if somebody creates a secondary next, then they won't be messed up. So I don't know, secondary space is a little, the name is a little bit under what it's doing. It's really like our whole free space. It's not just for secondaries, but we're putting strings in there too, and maybe other stuff. I guess arrays are sort of in there as secondaries, but yeah, we don't need a header for it because we're just passing the address around. All right, so that'll do that. But then, where do we do that stuff? Well, I guess it's in whatever that header stuff is, right? So, because in the header we write the string here. There's a make header. Am I misremembering? Make header. Define header. It's not REPL. Oh, it's like core. No. Well, that's all dictionary header. Well, he might have to do it too. No. Where would I have that? Is there a define? Secondary. Oh, colon, where's that? Somewhere. Define string. That's the one. Okay. So define string, you give it a word, put the word, and then we have to adjust. And we're doing this. Really, we just need to kind of do the last part. Because we've been bumping secondary space along as we went. So this kind of stuff, I don't know if that's a... plus x0. Oh, good point. Yeah, we can do that. I'm a little lost in this rounding off thing, but sorry, make string. Right. Before he does this, he should push secondary space. Okay, so he's pushing the return value, and then he's backfilling all these things. But I don't know. I'm looking at that. Add x0 gets x0 plus 8, and then we AND it with minus 8. That does seem like what would do this. Now, this seems weird to me. Add x secondary space gets secondary space plus x0. Oh, that's the length? Okay. Yeah, so it's taking the string length and then it's rounding it up. But this is kind of the thing to do. I guess I would call it kind of an assembler macro. Let's put it in there. Okay, so it adds 8 to the register, which sends it a whole word past. Then it takes off the last 3 bits, so it comes back. Okay. And we'll get this going in our test first, then we'll come back. Okay, so I want to round up 8 on secondary space. Now this is all local stuff, so I don't need to do a prologue. Okay. All right, so we pop that address, the word address, the array. We push secondary space, which is where we're going to, the address that we're going to copy into. We run through the loop, which should copy each word. It loads words and it stores the bytes, okay? And then at the end, it stores the 0 that terminates the string and increments this again, secondary space again. And then it rounds it, secondary space up, so next time somebody starts to write a header, they'll be on a proper boundary. Okay, and well, I lost this. Okay, so that one failed. Theoretically, this should pass. Boom. Okay, string.o post error invalid for operation. Can I do a ZXR? WZR. Store byte X1, X25, line 71. What? String.o. Store byte X1. Oh, this should be W1, yeah. String, right? All right. Okay, so let's see. All right, well, let's save it since it's good. Make dollar converts array to string. Okay, and now let's try it. Those all changed because I changed the macros. All right. So what we need to do, let's do getc. Let's make a 10 character array, and this is words. Okay, and now dot should have an address. Oh no, that's Lily's. Words should put an address on there. Yeah. Okay. So what I want to do, well, let's get our documentation. We're going to have to update that in a moment anyway. Okay, so at plus equals mem sub c sub b equals a. So push the array, push the index, push the value. Okay, so push the array. Well, I already did. Push the index. And then the value is getc. Is that going to work? No, it's got to be on the stack. Okay. And then at plus equals. Yeah, I'm afraid to create a loop first. That's probably a bad sign. All right, but I think this should work. I'll get a character X. Okay. Now I'm going to do words 1 getc at plus equal. I'm going to do a dollar sign. Okay. Now, if I do, I didn't install it. Theoretically, if I did make dollar, words make dollar, I would have whatever the first typed, X in the first cell, dollar in the second cell, a 0, we initialized it with zeros, so it should be in the third cell, and then words make dollar should give me a string that I can dot print. So, well, that's not right because dot dollar doesn't know about, it's trying to print a word array instead of a string array. Okay, so let's go back to main. I don't know, I've forgotten this one so many times. Where's my string ones? Well, I don't really have a string block, do I? Okay. Make REPL. Make string. It's not global. Make string. Did I put an S on there? No. Did I leave string off of a make file? REPL does not have string. Okay, so it was 10 array words. And then we're going to do, well, that's that. Then we're going to do words 0 getc at plus equals. And I'll read a character. G, words 1 getc at plus equals. I'll read a character. 2, read a character. Now I've got 1, 2, 3 characters followed by a 0 word because we allocated 10 and we only used 3. If I do make dollar, that should take that. Nope, I got to get the address on there first. Words make dollar. That should turn it into a string on top of the stack. And if I do dot dollar, I should get go. All right. Woohoo. So, yeah, let's make a loop. Let's define foo. Okay, so let's find, if I do, I don't have a four counter thing, so I'm just going to push 5 on the stack. I'm going to do I'll duplicate and then 1 minus. So that's not yet 0. Oops, do. Okay, so, oops, this is while. While dupe 1 minus. So that's while n equals 5, while n minus 1 not equal to 0, do getc. Well, let's do, a for loop would be very convenient for this. While not, I need the opposite order, or I could put it in backwards. I'm kind of doing that wrong anyway, aren't I? I want to take the 5 minus 1, no, 1 minus dupe. Okay, that leaves me the 4. I'll test the 4, do, and then well, somehow I want to do a getc, but I got to have stuff there to put it on. So I want words, and then I've got the 4 duplicated. So I'll push a 4. I'll swap. I'll subtract. So I have 4 on the stack. I'm going to put 4 on there. If well, it happens to be the same, but let's say I came through again and it's 3 is the value. 4 minus 3 is 1, which is the slot where I want it. Well, this is why you make definitions. All right, so now I have a 0 on the stack for the first time through, which I've got words, then a 0, and now I'll put a getc and do an assignment. Okay, so that should assign the word, the character into the word. All right. And then when I'm done, my word is okay, but I need to do a make dollar, words make dollar, and we'll print it. Semicolon. Okay. Well, our experience so far is when I type a line of text like this, it doesn't work. All right. But anyway, so I should get prompted 4 times. So 4, 3, 2, 1. When 0 comes up, it exits and it should print the word. Okay, so I need a 4-letter word. Okay, we'll take that. Oh no. Done? Oh, it's odd. Ha. Foo, 5, while, 1 minus, do, words 4, swap, minus, getc, at plus equals, odd, words make dollar, dot, dollar, semicolon. Okay, so words is there. I should be able to say foo, and then get prompted for 4 letters. So, well, let's do, oh, boom. Okay. Yeah, there's just too many 4-letter words. Unfortunately, I did not do something right. Let's do this again. We'll make REPL. foo that. Oh, well. Oh, interesting. Okay. 10 array words. Foo that. And if I run foo, make sure I know when it's blowing up. F, and then it bombs. Okay. This is probably where it would have been nice to like make add equal to a bounds check or something. Well, what can I do? I guess, yeah, do I need to swap more? All right, so the way I do this it's been a long time since I did any fourth, and I never did that much, but what I normally do is trace the stack. So let me, well, this probably wouldn't be good. I don't know. I've got this page. Okay, let's add a page here. Well, let's just do a bullets page. All right, and I'll copy this. Okay, so my stack on the first one, it looks like 5, and then it looks like 1 minus turns into 4. Dupe turns into 4, 4. Words. Whoops. 4, 4. But then do says, let me look at that 4, so it consumes it. Okay, so then we get words. Another 4. Oh, yeah, no, swap is wrong. Okay, because we want the third word down, not the second word down. So the third word down, let's see, we got cab. Cab makes it, yeah, cab would be better. So let's say we did cab. That would turn the stack into words for 4. And then 4 minus that is right. So minus would become words 0. And then we do getc and get a character and then store that into words 0. So this is the character and then empty. Which is bad. Because we lost a word on our stack too. Okay. Probably before the 4. So the problem is we don't have a 4 at the end of our loop here. So I'm going to do dupe because we need 1 at the end. Okay, so this one gives us 1 to consume. This one means we have something lying around when we get back. Okay, so let's try this. Fish. All right. Let's do it again, but foo 6. Well, 1 minus doop doop do words for cab minus getc at plus equal od words make dollar dot dollar semicolon. Ah. Okay, I don't know. That resembles our other bus error. I thought I had a clever way to go. Okay. Well, we're due for a break. I was going to type break, but I'm not going to debug it before break. Okay, so we'll come back in 3 or 4 minutes, see if we can figure out what's going on with this thing. It should work multiple times in a row. I'm not sure why it doesn't. All right, see you in a few minutes. All right, welcome back. Yeah, I think good suggestions there. I think there's a good chance that's the problem. Well, I shouldn't say that. That's certainly wrong, but there may be more wrong. All right, so we'll do 10 array words. I think the difference is this should probably be 5 by analogy. It's 1 less, but that also tells me the indexing we're doing is just a little goofy. Well, I don't know if I want to rewrite this or not, but let's first try this with the 6 and do words 5 cab minus getc at plus equals odd words make dollar dot dollar. I mean, I think we could work out a better loop that went from 0 to n, and that would be much more straightforward. Okay, and now if I do foo break, okay. Yeah, all right. But on the other hand, I mean, this seems to be what we're after. I think we can put it in a loop. We're back in echo mode in here. This is all great. Okay, so what's our status here? I don't know if we've modified a little bit. Okay, well, while we're filling this, let's get this README. Do I have string? No. Okay. Yeah, let's add a category for that. String dot dollar. This prints string from address A. And make dollar. That needs sound. Maybe we'll go for 1978 sound. I don't know. Yeah, teletype, right? Control G was Bell. We need a buzz for our hangman, right? Bzz. All right. Address array, each with character numbers with 1 character number per word, ending with a followed by a 0 word. It gets converted to string, and the address array address replaced by the string address. Okay, and then let's just see if this is looking coherent. I know I have a markdown editor somewhere. Here it is. Okay. Oh, I should say non-destructive there too. Maybe on the stack. Okay. That feels good. Let's, oops. What's, okay. Yeah, a random number generator would be good. I don't know how hard just getting a boop out. I don't know what's involved in that, but I think you're right for the games and stuff we might do. At least for Hangman, it'd be nice to have it choose some random string. Okay. Yeah, let's add that. I don't know if that's sort of pseudo arithmetic. I guess it's as good a place as any. And okay, what do we got to do? Read from file. No. We did add this. Okay. Nice. Okay. Well, is that a web page? Okay. Random function in Swift. Maybe this would be nicer if you pushed a number on the stack and you got a random number from 1 up to that. Maybe it's 0. Yeah, if you push n on the stack, you get a number and call random. You get a number from 0 to n minus 1. I think that would be handy. Well, I'm just going to let the system give me one, and it's just random. Oh, I'm not in. Why am I looking at Swift? Oh gosh. Yeah. What's a call that would get us this? Well, I don't know. Let's look for simple. It doesn't have to be super random number. No, I don't. Let's try algorithm. I don't even need very good random numbers. Maybe this will tell us. Right. Well, I actually want to. I'm going to dig out an algorithm book. Knuth. I think this volume, second volume, I think it has random numbers in it. Yes, 9. Okay, so right, let's take this random numbers. Okay, so the formula is x n plus 1 equals a times x n plus c mod m n greater than or equal to 0. Okay. Yeah, I mean, there's only c equals 0. It's a little faster. Okay, yeah. Well, I mean, this is getting back. I'm getting articles from the 50s and 60s he cites to do it. Take the little bits, the current. Yeah, we could probably do something like that. Yeah, I mean, right. The high bits are going to be. Well, I mean, we could use that for the seed, or we could just put a seed command in that took the seed. But I was hoping he would just tell us, like, use these 5 numbers and you're golden. A clever technique that is less commonly known: perform computations modulo w plus 1 with c equals 0. Ax mod w plus 1, but they don't tell you what w is. Is that the word size? So yeah, he says basically x sub n plus 1 equals a times x sub n mod word size plus 1. Okay, so in our case, 65, I guess. It doesn't seem like a very good range, does it? Prime factors of w plus or minus 1. Okay, 64 is, oh, 2 to the 64th plus 1 is like some obnoxiously huge number. 274177 times 6728042131071. Okay, so it's not very prime. That much is good. But I don't get, I mean, it would seem like you'd only get numbers in the range 0 to 64 if you picked W as your size, which is maybe good enough for us. And then I don't know how he chooses. I mean, I would pick some prime number, I guess. um, C has to be relatively prime to M. Well, 65 is it 5 times 13? Yeah. So prime to M, P equals A minus 1 is a multiple of P for every prime dividing by M. B equals A minus 1 is a multiple of P for every prime P dividing M. A minus 1. It has to be a multiple. Sorry. The claim is B equals A minus 1 is a multiple of P for every prime P dividing M. And we're going to use 65 as our word size plus 1. Oops. Okay. So, well, 65 is 5 times 13, right? 65 equals 5 times 13. So B needs to be B equals A minus 1 is a multiple of those primes. Well, I don't know how you get that. Okay, so it has to be a multiple of P. Okay, B has to be a multiple of P. So some number like 10 or 130 or something like that. Well, if it's a multiple of every prime. Yeah, maybe I'm overthinking it. All right, but if it's a multiple of every, so I guess you could say 5 to the nth times 13 to the k, and then is A minus 1. So that plus 1 is A. So we could take, right, let's do it. Let's take A equals, what's 125 times 169. Or that's B plus 1. Okay. Well, that's another way, right? We could just generate a bunch of values and call it a day. But I think Well, what would be easier? I don't know. This is kind of cool, a little mathematical. But if I'm dividing by 65, like, what's, I don't know how I get beyond 0 to 64, right? I mean, well, 64 is 6 bits. I mean, I guess I could generate 2 words. That would have 12 bits. That's 4,000 different values. That's more than we need. Even 64 values, right? If they're not just sequential, then that's not bad. All right, let's do it. Gosh, oh, where is that? I was reading this stuff on the old games, and they had the weirdest little thing. It was like it would take 2 bits, XOR them, like take take the value of 2 bits, shift the word some number of bits, and then XOR it back with the value shifted or something like that. And it generates just enough primeness or just enough randomness to kind of be plausible for things. But it's a pretty short period. I think it was only like 256. Okay, so yeah, so I guess random. What's the test? Okay. Well, unary op test, it's kind of that. So we're going to give a number, and then random number is going to be in 0 to that. All right. So unary op test. Well, this is not a good test. We don't want a consistent value. We're going to write our own test. Okay. But this can be a starting point. Random puts number on stack in range. Right. Okay. So you're going to put a number on the stack. Let's do data. Well, address VPC L data. No, we don't want that. Let's push a number on the stack, like 7. Move x0 #7. Data push x0. And this has to be with data stack init. Okay, and then if you BL random, you should get a value on the stack. Well, I kind of think 3 values the same in a row would be very suspicious. But, all right. Is that enough to tell? Okay, that's my act, actually. Okay. And then, well, I'm going to pop x0. I don't want to compare. I don't think we have a certain not equal. AS unit. Assert equal strings. assert true. Okay. Oh, okay. U32 is random static. So that gives you a value in some 32-bit range. Yeah, let's do that. Okay. But how are we going to know we got a test? Well, I guess one thing is we want to make sure this value is positive. So data pop x0. Let's just do data top x0. Okay, and then CMP. Well, x0 to 0. Now we have these environment ones. Is that environment? Right, the first page. So GT sign greater than, we want sign less than. If it's less than 0, well, no, if it's greater than 0, it's okay. So b.gt. Okay. And if it's not less than 0, then we got x0 there. I guess I can put if it is less than 0, we want to fail, so it can't be equal to 0. Okay. All right. So this is check that value greater or equal to 0. And this one is value is less than original value 7. Maybe this is LT. Pop x0, move x1 7. Compare x0 to x1, and if it's greater than or if it's less than, it's okay. Okay, and if it's not, x1 is 7. No, we don't want to assert equal. Let's move x1 to 0, get 0, and then assert that the value that's greater than 7 is equal to 0 will always fail. Okay. I think that's something. All right, and then random. Okay. We only have ints. Okay, so these are the range A to B. Yeah, so they scale it when they. I mean, we can just take it mod whatever, but you keep the seed up at 32 bits, and then the value is returned based on that. Okay, global random. Okay, so that, and then we need the test in the list. Okay, so, whoops, it's out of the way. I'm going to make /arithmetic test dot out. Now, did this. Okay. Fine. We have stack. Data underscore stack underscore init. I guess arithmetic tests needs to depend on stack. My makefile. Arithmetic tests does depend on stack. What happened? Data stack init. Unrecognized. Oh, BL. Lower range is 0 than mod B is the result. Yeah. Okay. ./arithmetic test.out. Good. Okay. So it basically has the number. Why don't I have two asserts? I guess I'm only asserting if I fail. Huh. Okay, so it is greater than 0, but it's not less than 0 because we don't do anything. Okay. All right. Arithmetic random. Okay, so we're going to need data. Data.text.align to. And this is there a good word for it? Well, seed's not really right because it's not the seed. But I think we'll. Okay. Quad. Okay. Now we got to do our arithmetic in W's, but that's okay. 3.459. Oh. No. Okay. Right. So we want to. Well, the first part is we got to do that multiplication stuff. All right. So we're going to load address. X0 is L seed. Okay. And then we're going to multiply. That constant looks suspiciously big. I don't know if this works. Well, no, I don't need it to. X0, I can load X0, and then I'm going to move X1 gets 910-230-123. 910-2. Okay, I got a feeling that's going to be too big. All right, and then we multiply. Oh, we just add that to the seed every time? That's pretty simple. Okay. Add X0, no. LDR X0, contents of X0. And X0 gets X0 plus X1. And then, well, let's do this. X2, X2, or maybe X1, contents of X0. This is X2, X1 gets X1 plus X2. And then store X1 back into X0. Okay, so that should get us a value there. Now, modulo. Well, we got modulo right here in arithmetic. Mod. Replace AB with B%A. AB is B%A. I want the opposite order. Okay, so I haven't pushed anything yet. Or I've got something there. I can let's get X3, and that's the value for mod. Now, is that always going to be positive? All right. Pop X3. Okay, we're going to do a push X1, push X3. Well, at this point, if I'm already going to be calling things, let's just call them. So I don't need to pop it. I'll just push X1. Now I've got X3, X1, but I want it to be swapped. All right, so we'll call BL swap, BL mod, and standard epilogue. Okay, so we have X0 pushed, and that's the input. Max of range. And output is number in range 0 less than A. Okay. Right. So I do think these probably need to be W's if they're doing U32s with that. So I can load it as X1, but then I'm going to manipulate it as W. But I'll store it back as X1. I don't see any harm in that. Okay. This should now pass. Yeah, too big. Okay. All right. Well, we know how to do this because we did it. Let's get our calculator on the end. Okay. So this is base 10. We're going to paste this in, turn it into base 16, 103641.026b. Okay. That was in our terminal stuff, which was io. All right, because we had to do this. Which seems like prime. Well, and let's say it should be a macro, but maybe it can't. By the time you figure out these two numbers, you've done all the work. Arithmetic. Okay. So the low bytes are 026b. Six B, and the upper bytes are 3641. Register is W2, yes. Thank you. Okay, let's try again. Oh, now that's coming because we don't print anything, I think. Let's just make sure that's not a crash. I probably should just do a neutral assert at the end. Okay, so yeah, he's just exited. Let's add that. Okay. X0 is 1. BL assert true. I believe we did that. Nope. Make sure it just takes what we think. X0 equals 1. Does not use X1. Okay. There we go. Okay. Let's screw something up. In arithmetic. Let me try putting this back. I don't know. It's still going to work. You can't tell with two numbers or one number. right? Because any number looks good as long as it's in range. And if our modulo is working, it's in range. So, yeah, you can't tell that error. All you can do... Well, let's run our REPL. 10 random, 10 random, 10 random, 10 random, 10 random. 1, 2, 3, 4, 5. Oh. Main. Okay, so it should have 5 values on the stack. Pop, dot, pop, dot, pop, dot, pop, dot, pop. And I should get Lily's next. Yep. Okay, 85296. That looks random. Random enough for our purposes, I'm sure. Okay, nice find on that little random function. Okay, so let's document that, or did we? Arithmetic, okay. Random. A, B, no, just A goes to R, where R is in the range 0 dot dot less than A. Oh, I can't. Have to know less thans or greater thans in your markdown, unless you mess with it. But this is fine. Okay. Yeah. All right. Well, this is good. Let's make sure everything's still green. I didn't double check. Okay. Good. Okay. Well, okay. I'm just going to do at this point. We've done this. That's a good thing. Okay. Yeah, we got digital dice. All right. Well, where we're at though, I think this is a great place to stop for the week. We've done everything we need to do to write a hangman, I do believe. I mean, there's some gaps. Okay. This is a refactoring. This is a feature we're not going to do unless we need to. These, we might have to come in and add a string feature or two. This is, yeah, it's a nice to have, not a must have. What if strings don't end by the end of the line? Yeah, that's nice. Array of strings, I don't know if we need it. I think we could do it. Explore whether we can use relocatable addresses. That's kind of a refactoring. These are some tools that we might wish we had when we start really programming. Like Yeah, would definitely be helpful. Better than a crash. Fill command for arrays, underflow, overflow. Yeah, control statements, debugging. Yeah, I mean, I think we may need some of this, but a lot of it we won't. So I believe what we'll do next week is we'll just start in on Hangman. And when we run into something that we just must have, like maybe split or join, we will stop and go back to implementer mode, go back to being a compiler slash interpreter implementer and do what minimal stuff we have to. But I think we can do a kind of a nice little hangman if we get going here. So there may be, well, there's some weirdness, but we'll give it a go. I think we'll get there. Okay. If we don't write bugs, we don't need debugging tools. That's right. Well, we will make a little TDD framework too. Not much fancier than we started with here, but just, something to assert equals and assert equal strings or something like that. I assume we can get that. We might have to add at plus or something like that, at plus dollar. Okay, but I think we'll do what we have to, but the core of it is let's just try and get a hangman going. I want it to look a little bit. I want to use some of the positioning stuff so it looks like meaningful on the screen, not just a command line mode thing. So I'm anticipating it'll pop up a bunch of dashes, maybe a scaffold, and say enter guess or something, and you type a guess and it'll show the list of guesses you used on the bottom. And if you miss it, it'll put a hangman piece on. If you get it right, it'll put it in the slots. It should look, 1981 game style, or pretty simple, but that's okay. I mean, we don't need to do that. I'm willing to go look up the VT100 codes. There are codes that will do. Well, we won't want to clear the whole screen probably, but there are definitely codes to position you at positions on the screen. There is a reset screen or, clear screen. I guess we could use it, but I think we can just replace the bytes we care about. But I think we can do something with it. We'll try and do a little bit of a library of functions. Now, I'm assuming my mode, I'm assuming, is that we're going to do like make REPL input some text in a file. I'm doing a here document now, but 1, 2 plus dot here. This thing will run. Well, I don't know what the word not found was, but it will run from a file, I think, if we do it like that. If I did less than file.txt or something. We may have, I don't know what that is. Well, we'll investigate next week. Anyway, it's been a good week. I'm happy we're getting to the end of the implementation piece, and next week we'll do Hangman. I don't see that taking, I'd be surprised if it takes all week. We'll see. I'm not quite sure what the next project is. One thing on my list is go back to KiltCalc and take in some lessons from what my wife and another person or two have looked at and get this thing shipped. So I got to go buy a PO box and register as an agent or a trader or something with Apple, but we'll do that maybe. I don't know if we'll be into that next week or not, but we'll see. And then if it's not KiltCalc, I've got other stuff in the pipeline. So anyway, have a good week. Have a good weekend. And I will see you Monday, I hope, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC. Thanks for everything, especially Mudsark 666. Take care. Bye-bye.